in this section, we're going to use our combination formula that we used in section 11.8 to solve some probability problems. So as we're setting these up, we're still going to be using that combination button and or use your factorial buttons if you want to work them out more step by step. But since most of these problems we are going to be looking at in dealing with a multiple different number of combinations, using your calculator to set these up is probably going to be the easiest way to do these problems. Right? So for example 1, a club consists of 4 men and 5 women. 3 members are to be selected at random to form a committee. What is the probability that the committee will consist of 3 women? Right? So we are looking for the probability that our committee will consist of 3 women. Right, so probabilities, thinking back to the beginning of this chapter, we're thinking about setting up a division problem. Right? So up top, we are going to come up with a total number of committees of 3 women. So how many different combinations can we have that way? So we're going to say the number of committees of 3 women. Right, and then we're going to divide it by our total number of possible committees. All right, so as we set this one up then, right, our numerator is going to be our number of possible committees of 3 women. Right, we have 5 women total, so we're going to do 5C3 to get our total number of committees of 3 women. Right, then to find our denominator. Right, our total number of possible committees, we're still going to be choosing 3 people. The difference is we have a total of 4 plus 5 is going to give us 9. So we're going to divide it by 9C3. Again, we're going to use our calculator to make this process and problem a little faster and simpler. 5C3 gives us 10. 9C3 gives us 84. Which we then could reduce our fraction to 5 over 42, or we could write it as a decimal 0.119. Right, as you're going through the homework, just pay careful attention. Are you being asked to write your answer as a reduced fraction, or are you being asked to write your answer as a decimal? So again, we have chose 3 out of 5 women for our numerator, and then 3 out of our total of 9 people for our denominator. Right, for example 2, in a flush game of poker, there's 5 cards of the same suit. If you were dealt a 5-card hand, find the probability that you will be dealt a heart flush. So in this case, we are looking for the probability of a heart flush. So what that means is we are being dealt, right, all 5 heart cards. Right? Number doesn't matter, but they all just have to be hearts. Right? So up top, we're going to have the number of different possible 5 heart hands. And then down in the bottom, we're going to divide it by our total number possible. Okay. All right, so up top, our number of 5 card hands where they are all hearts. We have 13 hearts, and we are picking 5. So 13C5 gives us 1,287 when we plug it into a calculator. Right down at the bottom, the total number possible. Right, if we're dealing with an entire deck of cards, we have 52 cards. So we're going to do 52C5, which gives us 2,598,960. We could reduce this to a fraction. It would take a little bit of work to try to figure out how to cancel or reduce this. So I'm just going to write this one as a decimal, 0.000495. Right, very small decimal, very small chance of this happening. All right. This next example, example 3, we're going to start on the bottom of this page and then carry it on to the top of the next page. Jennifer has 4 Scooby-Doo DVDs, 5 Magic School Bus DVDs, and 3 Bob the Builder DVDs. If Jennifer randomly selects 4 DVDs for her children to take on a road trip, determine the probability that, so for A, no Scooby-Doo DVDs are selected. So no Scooby-Doo DVDs are selected. All right, so looking at the information that we're given, right, we have a total of 4 Scooby-Doo DVDs, 5 Magic School Bus DVDs, and 3 Bob the Builder DVDs. So if Jennifer randomly selects 4 DVDs for her children to take on a road trip, determine the probability that no Scooby-Doo DVDs are selected. Right, so looking at our different groups that we have here, right, we have 5 Magic School Bus and 3 Bob the Builder. Right, so if we don't choose a Scooby-Doo DVD, that means we've chosen, right, a combination of the other 2. So between that 5 and that 3, well, we have a total of 8. Right? So our numerator is going to be 8C4. Right, then in our denominator, right, the total number of possibilities, well, if we add up 4 plus 5 plus 3, we get 12. So 12C4 is the total number of combinations that we have. 8C4 in our numerator, if we type it into a calculator, we get 70. In our denominator, we get 495. We're going to reduce these. Both 70 and 45 are divisible by 5. So if we reduce each of these by 5, we get 14 over 99. Again, as you're going through your homework, pay attention. Are you being asked for a decimal or are you being asked for a fraction? Okay. All right, so to answer B, we're actually going to use our answer from A. Right, so in A, we were asked to find the probability that no Scooby-Doo DVDs are selected. Well, B, we're asked to find the probability that at least one. Thinking back to complements, right? The idea that none and at least one are complements should be something that we are thinking about. So if we are looking for a probability of at least one Scooby-Doo DVD being selected, it's the complement of what we just found in our previous problem. So we're going to take 1 minus our probability of none. So that means we're going to take 1 minus 14 over 99, which is then going to give us 85 out of 99 for our probability for that one. So as we're going through and as we're thinking about these, our probability of none and our probability of at least one are complements. So anytime that you see probability of at least one in your homework, if you've already found your probability for none, then you can use that previous answer. All right, then for C, we are asked to find the probability that 2 Scooby-Doo DVDs and 2 Magic School Bus DVDs are selected. So here we're looking for the probability of 2 Scooby-Doo and 2 Magic School Bus. All right, so up top, looking at our Scooby-Doo DVDs. If we go back to the original problem at the bottom of the previous page, there's a total of 4 Scooby-Doo DVDs. So we're going to do 4C2 for our Scooby-Doo DVDs. Right, and then we're going to multiply this by our number of Magic School Bus combinations. So Magic School Bus, we have 5, right, and we're selecting 2 out of those 5. So our numerator is going to be 4C2 times 5C2. Our denominator, just like A, is going to be 12C4. Right? We're still taking this out of our total of 12 DVDs. Okay. All right, so up top, 4C2 gives us 6, 5C2 gives us 10. Down in the bottom, we get 495, just like we did in example A. Right? That's going to give us 60 out of 495, where if we divide both our numerator and denominator, in this case they're actually both divisible by 15, or we could divide them by 5 and then divide them by 3 in our next step. This reduces to a fraction in lowest terms of 4 over 33. All right. Example 4 is going to be similar to our last part on example 3. Okay, so as we're looking at these, we're going to find a few different combinations to multiply using, again, our counting principle in our numerator, and then divide it by our total number of different possible combinations. So Connor's rare coin collection is made up of 8 silver dollars, 7 quarters, and 5 dimes. Connor plans to sell 8 of his 20 coins to finance part of his college education. If he selects the coins at random, what is the probability that 3 silver dollars, 2 quarters, and 3 dimes are selected? So we're looking for the probability that $3, 2 quarters, and 3 dimes are selected. So in our numerator, we're going to have 3 different numbers that we are going to multiply together. All right, so looking at silver dollars, he has a total of 8 silver dollars in his collection, and we're picking 3. So we're going to have 8C3 times 7C2 times, we have 5 dimes, so 5C3. Okay, in our denominator, if we add up 8 plus 7 plus 5 gives us a total of 20. So 20C, and we're choosing a total of 8 coins. So we're going to have 20C8 in our denominator. Okay. In our numerator, if we multiply these out, so I've typed them into my calculator and multiplied it out, we get 11,760. In our denominator, we get 125,970. As far as reducing this one goes, we could reduce it into lowest terms as a fraction, or we could divide it out to give us a decimal. Right. So if we divide this out, this gives us 0.093, or about 9.3%. Again, as you're working through these problems in your homework, feel free to use your calculator to assist you to find your combinations. And then when you're entering your final answer into your homework, make sure that you are entering it in the correct form. Is it supposed to be a reduced fraction, or is it supposed to be a decimal?